In this video, we're going to introduce compounds and their chemical formulas. We will be adding information to this as we continue through the semester. So let's start by looking at the law of definite composition. This is a natural law, and you can read along with me. It says that compounds always contain the same elements in constant proportion. So I always like to use water as an example of this because it's information that most of us come to class with. So if I asked you for the chemical formula for water, you would tell me H2O. And nobody ever tells me different because water has a definite composition. It always has hydrogen and oxygen in the proportions shown in its formula. So it has 2 hydrogens and 1 oxygen. And so that's when they talk about the law of definite composition, always having the same elements in the same proportion. Water would be an example of that. So regardless of the origination of or where the water came from, it would be H2O. It would have that same composition. Now the chemical formula, which I wrote there as water, H2O, does tell you the types of elements that are there and how many are there. So we use the subscripts, you can see right here, subscripts, to show how many of each type of element we have. Now, I would like to, at this point, just introduce 2 words you may or may not be familiar with, but we do use them in talking about formulas of different things. And you can use these also in other disciplines, not just chemistry. But when I say subscript, this just means that it's written below the line of the writing. So for example, if I have H2O, the 2 is written as a subscript, okay? There's also superscripts, and this would be things that are written above the line of the writing. We're going to learn about something called an ion, and ions use superscripts to tell their charges. So here, a superscript would be like what the 2 plus is. So I just want to introduce you to those 2 words. So if you hear me say quickly superscript or subscript, then in your mind you know that I'm talking about something below or above the writing. Okay, so back to the formulas. In the formulas we use subscripts, so below the writing, to indicate how many of each type of atom there are. If there is no number written, then that means that it is the number 1. So here's several examples for you to review. There's water. There's a form of sugar glucose, which is C6H12O6. And then this is something called magnesium nitrate. Now, magnesium nitrate has something a little unique in that it has parentheses. I'm looking down here where my pink marker is, and then a number outside the parentheses. So that number outside the parentheses, like in math, gets multiplied through to the elements inside the parentheses. So if we were looking at this formula, the magnesium, which is outside the parentheses, does not have a subscript, so there's just 1 of them. The nitrogen, if you take the 2 outside the subscript and multiply it by the 1, you would have 2 nitrogens. And then for the oxygen, it's 2 times 3, so you have 6 oxygens. So just remember, if there's a parentheses, the number outside the parentheses gets multiplied in. And any elements outside the parentheses, they don't get multiplied. All right, so you might just want to review the 3 examples I gave below to make sure you're on target with what your understanding is. And then I have a couple examples. So here it just says, what is the total number of atoms in caffeine? Now, if I were you, I would pause the video now, get an answer, and then you can check what you think. You're checking yourself, okay? All right, so to determine this, you might be able to do it in your head, but for everybody out there, I would say carbon has 8 of them. Hydrogen there's 10 hydrogen, and I'm just looking at these numbers. Nitrogen, there are 4, and oxygen, there are 2. So to figure out the total, we would just add this together. So let's see, that's 18 plus 4 is 22 plus 2 is 24 atoms total. And hopefully I added correctly. Let's see, 6. I think I did, but if I made a mistake, I'm sure you can let me know. I appreciate it. Okay, so that's one. Let's try a second one. So this is written more as a multiple choice. Pause, answer the question, and then I'll come back with the answer. Okay, so this question is asking just about the hydrogen atoms, not about the total. And here, this is calcium acetate. And so let's look here. So hydrogen, here's the hydrogen, and so there's 3 in there. But notice there is a parentheses and a 2 outside the parentheses. So we're going to multiply 2 times 3, so the answer is letter D, 6. Now I'll just break down all of the elements for you. If you want to pause and do that yourself, you can, and then check yourself again, but just as an extra check to make sure we've got it. All right, so calcium, there's just 1. So it's outside the parentheses. It doesn't have a number. We know when it's not a number, it's 1. Okay, carbon, there's 2 inside the parentheses, and 2 times 2 would be 4. We already decided that hydrogen is 6, and then the oxygen, 2 times 2 is 4. So that's if I broke it down individually. So one last thing for compounds that we're going to, again, build on this knowledge, but just as an introduction, connecting it with the elements and the type of elements that are in compounds. So the compounds that we're going to be talking about, there's going to be 2 general categories, something we call molecular and something we call ionic. So molecular compounds are also referred to sometimes as covalent compounds. And how we identify them is molecular compounds form between 2 nonmetals. So when we look at a formula and they only contain nonmetals, they are called molecular compounds or covalent compounds, and they exist in something that we call a molecule. Hence, molecular compounds, they come in units called molecules. So examples could be water, H2O, that's all nonmetals. It could be one of our sugars, glucose. It could be something like hydrogen peroxide, which is H2O2. It could be carbon dioxide, CO2. So when I look at the formula and I see all nonmetals, these are molecular compounds and exist in units called molecules. Now, if you're not remembering what metals and nonmetals are, their location on the periodic table, I have a previous video that goes over how we could determine using the periodic table if an element is a metal or a nonmetal. So that's molecular compounds. Ionic compounds are the second category, and how we'll identify those is they form between metals and nonmetals. So when metals and nonmetals get together, they don't form molecules, they form something different, and we call them ionic compounds. So ionic compounds can be things like table salt, which is on the video. Here I see illustrations of sodium chloride. Sodium is a metal, chlorine is a nonmetal. Whoops. On a previous one, on the previous page, I had calcium acetate. And calcium acetate, here are metals, a metal. These are all nonmetals. So it's still, even though it's not one of each, I'm having trouble spelling nonmetals. I don't want to get that extra in there, nonmetals. It doesn't matter that there's more nonmetals than there are metals. It's metals and nonmetals. We can have other things. For example, I could have magnesium hydroxide. Again, metals, nonmetals. Or I could have sodium sulfide. Again, metal, nonmetal. Now, one thing you might notice, which we'll get into a little bit later, but when metals and nonmetals come together and we write the formula, the metals are always written first. So you may notice on all my examples, it was a metal and then a nonmetal. And that's not a coincidence. That is how we will learn to write the formulas. So in this section, I want you to be able to associate compound formulas with the number and type of elements that are present. I want you to know the law of definite composition, and I want you to know these two categories, molecular and ionic compounds, what type of elements are involved in each one, and that molecular compounds form molecules and ionic compounds do not.